Hello and welcome back everyone. This is our last example on integration by parts. It's the integral of e to the 2x times sine x. So again, it is not too unusual to think that the integration by parts might work in the situation because it's a example where you have product of two functions being integrated, right? And u substitution clearly does not work. You know, what would you let u be equal to, right? So that's completely out of the question. So it's not unreasonable to say, okay, let's just try integration by parts. We got to let u be something and dv be something else. Now, usually, unless you have like natural log or you have some unusual situation, usually we let u be something that is easy to differentiate and dv be something that is easy to integrate. Now, in this situation, both of these are relatively easy to differentiate and relatively easy to integrate. So you really have a choice, and it doesn't matter which way you go in this situation. Okay, so you can go with either way. So in my case, I let u be equal to sine x. Okay, I just like differentiating sine better than integrating trig functions. So I'm just going to put u equals sine x and dv be e to the 2x. But just know that you could have done the reverse, and at the end we would still get the same final answer. Okay, so from u to du we differentiate, and we will have derivative of u is sine x is cosine x dx, and here we anti-differentiate. We're going to get e to the 2x over 2. And applying the integration by parts formula, which is uv minus integral v du. So beginning with u times v, so it'll be sine x times e to the 2x over 2. And I pull the 1/2 up front, minus integral of v du. So minus, you'll multiply these two together under an integral sign. So it'll be minus the integral of. And when I do that, I usually like to pull out any constants, like 1/2 in this case. And within the integral sign, I'm going to have e to the 2x times cosine x dx. Okay, now you might look at this and you might say, wait a minute, have we wasted our time here? Here was e to the 2x sine x, and here it is e to the 2x cosine x. You know, what is going on here? It looks like I'm drawing in circles here. But continue with this one more time, and you might actually see the end of the tunnel here, and we get out of this circular looking problem. So the catch is, whatever you let u here, like if you let u be the trig function, follow the same pattern. Let u be the trig function here as well. Okay, so we're going to use integration by parts again. Let u be cosine x and dv be e to the 2x dx. Okay, so once again, u to du differentiate, you get negative sine x dx. And dv to v anti-differentiate, and you get e to the 2x over 2 over there for your v. So once again, we're going to use integration by parts using this formula on the top of the page. The first piece here, of course, from the previous line will remain the same. Minus 1/2 will remain there. But instead of this integral, I'm going to use integration by parts formula in there. I'm going to open the parenthesis and start plugging in things in there. Okay, so we begin by writing the first piece as it is just copied down from above. 1/2 e to the 2x sine x. Done. Minus 1/2, copy that from above. Okay, now open the parenthesis and start applying integration by parts formula to this integral. Okay, so u times v will be e to the 2x over 2 times cosine x. So e to the 2x over 2 times cosine x. Okay, and then minus integral of v du. So minus, I need to integrate this product. Now, that in itself is bringing another negative, right? So there's a minus coming from the integration by parts formula, another minus from this product. So those two negatives, when multiplied, will give me a positive. So I'm going to put a positive in the middle, and then this 1/2 I can take outside of the integral sign, and I need to integrate sine x times e to the 2x. Okay, you might still say, okay, is this really going anywhere? Take a look, because we began with integral of e to the 2x sine x dx, and we ended up with the same integral over here, right? Is it helping? Okay, just be patient. I promise you this is going to work. Let's just keep going. Okay, so multiply the negative 1/2 times the first term, negative 1/2 times the second term. So, and don't forget to bring down the very first term. So bring that down. Here you're going to have negative 1/4 e to the 2x cosine x. Here you're going to have also negative 1/4 times the integral of e to the 2x sine x. Okay, so at that point, we see that there is a repetition. We see that this integral is the same exact integral as what we were trying to find in the first place, right? So I'm going to call it I, the integral. Okay, that's the unknown. We're trying to figure out what I is. You could have called that Z if you like, whatever you like, an unknown, right? So what I have here is over here I, over here I have minus 1 over 4I. So I'm supposed to solve for I. So let's put the unknown I on the same side. So I add to both sides plus 1 over 4I. So now you will have I plus I over 4, and this will disappear, of course, equals all of this on the right-hand side from here to here. So 1/2 e to the 2x sine x minus 1/4 e to the 2x cosine x. Okay, at this point, to solve for I, our unknown, I'm going to get common denominators. So on the top you have 4I plus I, or 5I over 4 equals the right-hand side. Right-hand side is unchanged. And finally, to solve for I, multiply both sides by 4 over 5. So do times 4 over 5 on this side, times 4 over 5 on that side. And I'm also going to add a plus c at the end just to represent the fact that this is an integral that does not have limits of integration. So these are going to cancel. So on the right-hand side, we have basically the answer to our question. I, the unknown, is 4 over 5 times everything else we had over there already, plus c. And if you wanted to, you could distribute the 4 over 5. That will be fine. Like 4 over 5 times 1/2, 2 goes into 4 2 times. You can have 2 over 5, right, for the coefficient of the first term. And then if you multiply it with the second term, there the 4's are going to cancel. You're going to have negative 1 over 5 e to the 2x cosine x for that one. And that's it, basically. That is our answer. That is the answer to the original question. And again, sometimes we factor it. It's not absolutely necessary, but if you look at the first term and the second term, you will see that you'll be able to factor out e to the 2x over 5. If you do that, you have 2 e to the 2x sine x. Excuse me, I took out e to the 2x. So all I have left is 2 sine x from this one. And what do we have left from the other one? So if I took out e to the 2x over 5, all I'll have is a minus cosine x plus c at the end. So again, it was unusual. Yes, these are long questions. I'm not going to give you too many of those, but I think you have a couple of them in the group activity and maybe 1 or 2 of them in the homework. So I know these take longer, but it's really good exercise, you know, checking your concentration skills, mental stamina, you know, ability to take a problem from the beginning to the end. So all those complexities add more challenge, yes, but yet it's, I think, worth your time to help you understand how to solve more complicated problems. All right, well, now it's time to go back and do lots and lots of mixed examples to practice this section. See you next time.